This video will focus on the end behavior of polynomials. So you can see I have filled in the sentence stems that we've been working on when you're really just filling in this one blank. You'll notice that both sentences talking about the positive direction and the negative direction are here for just this one polynomial. You have to be able to describe as it's going out to the right, where x is getting more and more positive, and as it's going to the left, where x is getting more and more negative. You have to do both directions for just one polynomial. So you'll notice in my second example, again, I have both of those sentences. One is not enough. You have to describe both directions. So the first thing you want to look for is the degree, right? My degree here is 2 because it's my highest exponent. That means I have an even polynomial. So both the positive and the negative are going to go in the same direction. So essentially I'm going to be filling in the same word here and here, depending on what my leading coefficient is. My leading coefficient here is -1. So what I do is I pick a large value either in the positive x direction or the negative x direction and test it out for that leading term. So I'm going to choose +6 just because I chose a number at random. So I'm going to plug that in to my leading term, which is -x². I'm plugging that in. So negative and then 6 squared. Notice that the negative is not associated with that 6, right? If it said something like -2x², I would plug in for x, do the square, and then multiply by -2. So this is really -1x². So I'm going to end up multiplying by -1 here after I square the 6. 6 squared would be 36. Multiplied by -1 is -36. This shows me that when I plug in a positive value, I get a negative value back out. So as x is getting more and more positive, my y values, or f of x, is going to get more and more negative. So it's growing in the negative direction. Now, because it's an even function, you can also test, right, a negative value here for x, and it will also show you that you get a negative number. So the same word is going to get filled in for that second sentence. My second function is a little bit different, right? Because if you look here, I have an odd polynomial. That's going to be split end behavior, meaning when it goes one direction, it's going to go positive, and then when it goes in the other direction, it's going to go negative. It goes opposite ways. And I need to figure out what that way is. So again, I'm going to pick a value and I'm going to plug it in for x in my leading term, because my leading term holds the most weight in my equation. So the rest of the equation is going to follow what that leading term does. So I'm going to pick a positive value and I'm going to pick a negative value to see what it does. So I'm going to pick, we'll say 3. Right, so in order of operations, I have to do the exponent first. So 3 to the 3rd power is 27. That's 3 times 3 times 3 times 2. That's going to get me 54, which is a positive value. So as x is getting larger and larger in the positive direction, g of x, or my y values, are also getting larger and larger in the positive direction. Then I would test a negative value. So I'll do the opposite, I'll do -3. So -3 to the 3rd is actually going to end up giving us -27, because -3 times -3, right, just as a side note, this would give us +9, but then multiplied by another -3 is going to result in -27. Then 2 times -27 would be -54. So I end up with a negative value here, meaning as x is getting more and more negative, so as I'm moving to the left, my y values are also getting more and more negative. Now that's not always the case, right? It doesn't always match up, so that's why we do this test of our leading coefficient, our leading term actually.